Hi, this is Mrs. Doris. This is lesson 2-3. In this lesson, we are going to be solving multi-step equations. Multi-step equations are very useful in solving real-life problems. To solve a multi-step equation, what we are going to do is to form a series of equivalent equations. To do this, we're going to use the properties of equality, addition, subtraction, multiplication, or division, and inverse operations, and work backwards until we isolate the variable, meaning we get the variable by itself on one side of the equal sign. All right, one of the first things that we need to do is we are going to combine any like terms that we have in the equation. So looking at our first equation, 11m minus 8 minus 6m equals 22, what we notice is that we have two terms that have an m in them. So we're going to combine those two. 11m, and notice I take the minus sign with the 6m. 11m minus 6m is going to give us 5m. Bringing down the minus 8 equals 22. Now, that's our first step, and now we're down to two steps. Again, we're going to work backwards. Reading the equation, 5 times m minus 8 equals 22. The last thing that I said was subtract 8. So we're going to use the inverse operation and add 8 to both sides. Minus 8 plus 8 is equal to 0. So I'm going to bring my 5m down on the left, and on the right hand side, 22 plus 8 is 30. All right, undoing my multiplication, 5 times m, I'm going to use division. So I'm dividing both sides by 5. 5 divided by 5 is 1. 1 times m is simply m. So now we have isolated the variable m on the left-hand side, and 30 divided by 5 is 6. Now, this is a great problem to use a calculator to check on. So, using your calculator to check it, you would take 11 times 6, which is what we got for m, minus 8, subtract 6 times 6, and make sure that you get 22. All right, in our next problem, negative 2y plus 5 plus 5y, we have two terms that are like terms, negative 2y and plus 5y. These can be combined. Negative 2 plus 5 gives us 3y. Bringing down our plus 5, this is all equal to 14. Working backwards, we're going to subtract the 5 from each side. That leaves us with 3y equals, on the right side, 14 minus 5 is 9. And then to undo the multiplication of 3 times y, we're going to divide both sides by 3. 3 divided by 3 is 1. 1 times y is y. Y is now isolated on the left-hand side, and on the right-hand side, 9 divided by 3 is 3. And once again, you can substitute the 3 in for the y into the original equation, and this is a great place to check using a calculator and make sure that you get 14. Problem 2. Solving a multi-step equation. Noah and Kate are shopping for new guitar strings in a music store. Noah buys 2 packs of strings. Kate buys 2 packs of strings and a music book. The book costs $16. Their total cost is $72. How much is 1 pack of strings? All right, well, let's take a look and see what the important parts to this problem are. All right, so we know that Noah buys 2 packs of strings. We want to know in our question how much 1 pack of strings is. So why don't we use P for our variable, and that's going to represent the how about not the number, but the amount of 1 pack of strings. All right, so in a word problem, you have the additional step of first defining what variable you're going to use to represent your answer. All right, so P is equal to the amount of a pack of strings. All right, so we know Noah buys 2 packs. That would be 2P. Kate buys 2 packs of strings. There's another 2P. And she's buying a music book, and the book costs $16. So we're going to add on $16. Our total cost is $72. So here is our equation. The first step that we have to do is to add together our like terms. 2P and plus 2P is going to be 4P plus 16 equals 72. Subtract 16 from each side. On the left side, we're left with 4 packs of strings, and they would cost, when we subtract 72 minus 16, we're going to have $56. All right, undoing the multiplication, we're going to divide both sides by 4. 4 divided by 4 is 1, so 1 times P is simply P. And 56 divided by 4 is $14. So each pack of strings costs $14. Label your answer. And then be sure that you check your work to make sure if we bought 4 packs of strings at $14 and a $16 book, that our total would be $72. Problem 3, solving an equation using the distributive property. This gives us a good chance to review the distributive property. Remember, you want to take, in this case, 3 groups of 2x minus 3 groups of 6. So writing that out, we're going to take 3 times 2x minus 3 times the 6. And that's distributing the 3 to each term inside the parentheses. 3 times 2x is 6x minus 3 times 6 is 18. Now, let's undo what was done to the variable. First thing I want to do is to get rid of the subtraction, so I'm going to add 18 to both sides. Minus 18 plus 18 is equal to 0. Solving now, 18 plus 18 is 36 on the left, and I'm going to bring down my 6x on the right. Now, I have a multiplication problem, 6 times x. I'm going to undo multiplication of 6 by dividing by 6. 6 divided by 6 is 1. 1 times x is x. So I have isolated my x on the right side of the equation this time. 36 divided by 6 is 6. So my answer is 6, and I can substitute that back up into my original equation, taking 2 times the 6, subtract 6, and let's go ahead and check this one. 2 times 6 is 12. 12 minus 6 is 6, and 3 times 6 is 18, so it checks out. All right, now, here's a question. Can you solve the above equation using the division property of equality instead of the distributive property? What they mean by this is, since our multiplier here is 3, could we simply not just divide this side by 3 and divide the left side by 3? The answer to this question is yes, we can. 3 divided by 3 is 1. 18 divided by 3 is 6. So 6 on the left side. On the right side, all we're left with is what was in parentheses, 2x minus 6. And then adding 6 to both sides. 6 plus 6 is 12. Minus 6 plus 6 is 0. And on the right side, I'm just left with 2x. Dividing by 2 to undo the multiplication, I get 12 divided by 2 is 6. My 2 over 2 cancels out, and I have x equals 6. Same answer that we got to the problem when we use the distributive property. But I want to bring to mind, not always is that going to work. If I change that multiplier to a 5, then in this case, if I divide by 5, 18 divided by 5 is going to give me a fraction, or at best a decimal, and I really don't want to deal with decimals until the very end, if at all. So this is a good example. Let's see, 18 divided by 5 would be 3.6. And then on the right-hand side, I'm going to have 2x minus 6. I'm going to have to add 6. Oops, and I've got to be careful here. I have to add the 6 to the 3. 3.6 plus 6 is 9.6 is equal to 2x, and then divide by 2. And this gets to be a little bit more complicated. I'd have 4.8 is equal to x. And you'll see, here I am, using this process, I am dealing with a decimal throughout all of my computation. And it can sometimes be not as easy to work with decimals and fractions in a problem like this. So this is a really good example of where I would distribute. 5 times 2x is 10x. 5 times a minus 6 is minus 30. Then add 30 to both sides, and you'll notice here I'm dealing with nice whole numbers. No problem. Negative 30 plus 30 is 0. 18 plus 30 is 48. On the right-hand side, I have 10x. And then divide by 10 on both sides. 48 divided by 10 is 4.8. So the nice part about doing it this way is you don't get a decimal until the very end. All right, and I think this is the preferable way to do it, to use the distributive property. Problem 4, solving an equation that contains fractions. I'm going to show you two methods to solve an equation that has fractions in them. The first method that we're going to do is to write the like terms using a common denominator and solve. All right, well here we have 2b over 5 plus 3b over 4 is equal to 3. 5 and 4 are relatively prime. They do not share any common factors, so we have to multiply them together to get our common denominator, which would be 20. Now, what we notice, in order to get 20 in our first fraction, we would have to multiply 2b over 5 by 4 over 4. 4 times 5 gives me 20 on the top. 4 times 2b gives me 8b. On our second fraction, we're going to have to multiply it by 5 over 5 in order to get 20 in the denominator. 3b times 5 would be 15b. Now we can combine our like terms. 8b plus 15b would be 23b, all divided by 20. All right, multiplying both sides by 20. And I'm going to move up here. 20 over 20 cancels out, and I have 23b is equal to 3 times 20 is 60. Then my last step would be to divide by 23. All right, in this problem, when I divide 60 by 23, I'm not going to get an exact answer. So you may be asked in the directions in your book to round it to a certain place value. I'm going to round this to the nearest hundredth, and because I am rounding it, I'm going to change my equal sign to is approximately equal to. 23 divided by 3 is 1, so 1 times b is b. And 60 divided by 23 is approximately 2.608. So to the nearest hundredth, there would be 2 and 61 hundredths for my answer. Now, the important thing to note here when you round off an answer is if you go back and check it in the original problem, taking 2 times 2.61 and dividing it by 5, and adding to that 3 times 2.61 and dividing it by 4, you will not get exactly 3. However, you should get very, very, very close to 3. All right, in method 2, what we're going to do this time, rather than find a common denominator, is we're going to clear the fractions from the equation so that we don't have to deal with them. Now, to do that, we still have to think about what number 9, 6, and 3, our denominators, all will divide into equally. So it's very similar to finding a common denominator. The easiest way to do this is to start with your biggest number, 9. And let's just make a list of multiples of 9, and we'll check to see if any of them work. I know that 9 won't work because 6 will not divide into 9 evenly. 9 times 2 is 18. Well, 3 goes into 18 evenly. 3 goes into 6, or 6 goes into 18 evenly, and 9 goes into 18 evenly. So I'm going to multiply both sides of my equation by 18. This will clear my fractions. All right, so here's what we have. We have 18 times 1/9 would be 18 over 9. Here we have 5/6 times 18. And then minus m over 3 times 18. All right, well, 18 divided by 9 is 2. That's the easy one. On the right side, the easiest way to do it is to note that 6 goes into 18 3 times. 5 times 3 is 15. Next, 3 goes into 18 6 times, and 6 times m is 6m. So at this point, I've now cleared all my fractions, and I'm just dealing with integers. 2 equals 15 minus 6m. Now, this equation poses a little bit of a different problem, and one that we have to recognize, because although this is a subtraction problem, I'm actually going to get, in order to get my variable isolated, I'm going to switch to a different color here, I have a positive 15. To get rid of it, I'm going to have to subtract 15. 15 minus 15 gives me 0. All right, 2 minus 15 gives me negative 13. And on the right-hand side, I have to be careful here too, because while I have 0 here, I have 0 minus 6m. Well, 0 minus 6m is negative 6m. All right. Now, to further isolate the variable, we're going to undo the multiplication by dividing by -6. -6 divided by -6 is 1, and 1 times m is m. On the left-hand side, we have a negative divided by a negative, which is simply a positive, and I'm going to leave my answer in the form 13/6. Or you may prefer writing it as a mixed number, 2 1/6. Problem 5. We're going to solve an equation that contains decimals. Now, method 1 is the method I call just deal with them. And by just dealing with them, we're going to do what we have done on all of our other problems. We're going to undo each of the operations. So to undo subtracting 2.325, we're going to add 2.325. And I'm going to do the same to the other side. Now, a minus and a plus cancel each other out. So I have 0.5x is equal to, and on the right-hand side, let's add these up. 5 and 2 are 7, 9 and 3 are 12, carry the 1, 1 and 3 are 4, and 2 are 6. All right, then I'm going to divide both sides by 0.5. 0.5 divided by 0.5 is equal to 1x. And on the other side, 6.275 divided by 5/10 is going to give me 12 55/100. Here I get a terminating decimal, so I'm going to leave my answer in that form. All right. Now let's use another method. We're going to do a different problem, but this time we're going to clear the decimals by multiplying by a power of 10. All right, so what you need to do is look at how many decimal places there are. There's 1 in 0.5. There's 3 decimal places in each of our other numbers. So in order to clear all the decimals, we're going to have to multiply both sides by 10 to the third power, which would be 1,000. And we're going to multiply the left side by the same number using the multiplication property of equality. All right, 1,000 times 0.5 would be, that would move the decimal point over 3 places, so I end up with 500x minus, moving the decimal point over 3 places, 4,973 is equal to, and multiplying 27 thousandths by 1,000, I get 27. All right, now we're going to undo the operations. But notice we're dealing with nice round integers at this point. Okay, and I'm going to rewrite my 27 so that it lines up a little better. All right, minus 4,973 plus 4,973 cancel out. So bringing down 500x on the left, and on the right-hand side, adding these, looks like I get 5,000. Oh, that makes my next step very easy. I'm going to undo the multiplication by dividing by 500. 500 divided by 500 is 1. 1 times x is x. And 5,000 divided by 500 would be 10. So there's my answer. And again, I can check it out by going back to my original problem and substituting in 10 to make sure that I get a true statement. If you have any questions, please bring them to class and we'll be happy to address them. Thank you.